Hello everybody, welcome back to the last section for Unit 10. Today we're taking a look at circles in the coordinate plane. So we've been dealing with circles all unit long, but when it comes time to take Algebra 2 or pre-calculus, we're going to be seeing a lot more coordinate math on a grid. Thus, it is super important that we take a look at the standard equation of a circle. But be warned, there is a slight typo. This r at the very end should be squared. The formula looks a bit complicated, but it goes like this. Starts with x minus h squared. H is how far to the left or right you'd like to move your circle. Then we have y minus k squared. K is how much up or down you'd like to move your graph. So if your graph is up 3, k would be 3. If your graph was down 7, k would be negative 7. The radius of your circle is going to be what r is. So from this alone, we can just plug our values into this formula and be done. There's very little simplification that needs to happen here. So let's take a look at exercise 1. Exercise 1 just has us write the standard equation of each circle, so we need 2 bits, the center and the radius. No matter what, the setup is always going to be the same. It's always x minus something squared plus y minus something squared equals radius squared. We just have to fill in the rest of the info. Let's start with the center of our circle. To find the center of a circle is a little bit easier in this example, but if you're ever having difficulties finding the middle, take the average of the number at either end of the circle, and you can do the same thing with the top and bottom. But we can all see that the middle of the circle is going to be 0, 0. So 0 is our first variable, 0 is our second variable. 0 becomes our h value, 0 becomes our k value. So this is x minus 0 squared plus y minus 0 squared. The last thing we need is the radius of this circle. To find the radius, find a distance between the center of your circle and the edge of your circle. You can go up, down, left, right, diagonal. Doesn't matter as long as you can find the distance accurately. But since we're on a grid, it makes sense to just go left and right. This line segment is 3 units long, so our radius is 3. All we need to do now is just simplify each piece. X minus 0 is just x, so we're left with x squared. Y minus 0 is just y, so we're left with y squared. And 3 squared is 9. So we're left with 9. Perfect. This is the standard equation of the circle to the left. I want you to give the next 2 a shot. Pause the video and see what you can do. How did we do? Let's start by finding the middle of this circle. The middle of the circle is going to be right about here. But if you don't believe me, you can do negative 9 minus negative 1 divided by 2. Because negative 9 and negative 1 are where the furthest parts of the circle are. If we took a look here, this portion and this portion. We're just finding the middle of those. Same thing for the y values. We can also just take the top y value of 8, subtract the bottom y value of 0, and divide by 2. Either way, we end up getting our coordinates for this. It ends up being negative 5, 4. Now, when we plug this into the formula, make sure we plug it in verbatim. It's always x minus your h value. And since our h value is negative 5, it's x minus negative 5, which we know we can simplify later. X minus negative 5 squared plus y minus 4 squared equals Our radius for this problem, you can take going up, down, left, right, doesn't matter, but the radius from center to edge is 4. So, 4 squared. That means our final equation can be written as x plus 5 squared, since minus negative is the same as plus y minus 4 squared equals 16. For part C, it already gives us the center and the radius, so we can just plug it in. X minus 0 squared plus y minus negative 9 squared equals 4.2 squared. This could simplify to x squared plus y plus 9 squared equals, and then 4.2 squared ends up being 17.64. So this would be our final answer. Things get a bit trickier when you get to exercises 2 and 3 because I'm not giving you all the information you need. You will need to find the information. So, we're told for exercise 2, the point negative 5, 6 is on a circle, so it's on the outside, with center negative 1, 3. Notice that we are missing the radius. We don't know what the radius is, so that'll be one of our goals for this, is to find the radius. To help you see this, I'm going to jot both of these points down, and we can see if we can build a circle based off of it. You can absolutely just set up your grid like normal. Just know that your circle isn't necessarily going to be in the middle of your grid. Here, we have the point negative 1, 3, so right here. And we have a point negative 5, 6, which is going to be all the way up by the top. Notice that because our circle is sort of by the edge here, it's probably going to go off the page a little bit. And that's okay. Folks, there are 2 ways to find the radius, one of which is very accurate and recommended, and one of which can help you in a pinch. In a pinch, you can use a compass to find the radius. Recall that to finish a circle, all you need to do is line up the center of your compass with the center of the circle, find which of the spots in your compass corresponds to the other point. So you see how my center is here, my other point is right here. Then use the compass to draw the circle. We could absolutely use this to find the radius. But I want to show you the best way to find the radius, because your radius is not always going to be a whole number. To find the radius, we're basically looking for the distance between these 2 points, right? So we can use our distance formula. As a reminder, the distance formula goes d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All we need to do is plug in the x and y points of our 2 coordinates, and we're good to go. So negative 5, 6 and negative 1, 3 we can plug into this formula. Instead of the distance, though, this will be our radius, r. So r equals the square root of all of this. Let's start with the x values. I'm going to choose to do negative 5 minus negative 1 squared. Again, you could have flipped these around, they would still give you the same answer. Plus the y values squared. The y values are 6 minus 3 squared. Keep the same order you did the first time. If you chose negative 5 as x2, 6 is y2. Alright, let's do this a little bit half mentally. The more you can do mentally, the more time it'll save you. So, negative 5 minus negative 1. Minus and negative is the same as plus, so this is just negative 5 plus 1, or negative 4 squared. What is negative 4 squared? Well, it's 16. This one's a little easier. 6 minus 3 is 3, squared is 9. So this is just the square root of 16 plus 9. Our radius is 5, which absolutely matches up with our drawing. Sorry. Once we have our center and our radius, we can write the equation of our circle. Our center is negative 1, 3. Our radius is 5. So the equation is, I'll write it down at the bottom of the page here, x minus negative 1 squared plus y minus 3 squared equals 5 squared. We can just figure out what these are. X minus negative 1 is the same as x plus 1, so we get x plus 1 squared. Y minus 3 just stays the exact same as it always was, and 5 squared is 25. Perfect. Before we start the next problem, I want to show you an alternative that might help you make cleaner circles. You see here the top part of our circle was sort of cut off by the graph. That's because we chose the origin of our graph, the center, to be the center of what we had. But are we given the center of a circle in these problems? It makes more sense to have the center of your circle also be the center of your graph. Just makes the graphing a bit weirder. My recommendation is make the center of your circle 1, 4 for this one, in this example, and make your graph around it. 1 means that it's 1 to the right of 0, so this is our y-axis. 4, for the y value, means it's 4 above the x-axis, so the x-axis will be down here. What we've just done is we made our circle the center of the graph, and it'll make it a lot cleaner when we graph the rest. So, if we also have the point 4, 1, we can take our compass, and once again, try and find what circle matches best. I think this one works out perfectly. I'm going to keep my compass centered, and I'm going to, oops, just after I said keep it centered, it slipped, so let me try that again. I'm going to keep my compass centered, I said. There we go. There's our circle. Again, you may be able to predict what the radius is, but in this case, be careful. I want you to actually solve for the radius and see why it's not what you think it is down here. Pause the video and see if you can solve for the radius. How did we do? It turns out the radius for this problem is the square root of 18? That's right. It looks like, according to our drawing, that it was about 4. But that little overhang makes a difference. Our radius is not a whole number on this problem. So that's why just graphing can be very quick, but not accurate. But we can still write our equation nonetheless. Down here, I'll write the rough draft. Our center is 1, 4, so it'll be x minus 1 squared plus y minus 4 squared equals the square root of 18 squared. Square root of 18 squared. And those keen-eyed viewers might recognize that the square root and the square will always cancel. So our final answer truly is x minus 1 squared plus y minus 4 squared equals 18. Again, because a square root and a square are opposites. Perfect. Let's try out the last problem, exercise 3. You may have heard of an epicenter before, but the epicenter of an earthquake is the point on Earth's surface directly above where the earthquake started. A seismograph is a machine that is used to figure out how far that machine is from the center of an earthquake. You're almost never going to have a seismograph just right on top of an earthquake. So it tells you, hey, here's where we are. Here's how far away the earthquake is. In order to figure out the exact position of an earthquake, though, you actually need 3 seismographs. We get to do something called triangulating the position. You may have seen in like spy movies or cop movies where it's like, we're triangulating the perpetrator's position. That's basically what we're going to do here. I'm going to show you how to triangulate something. So, we have 3 seismograph readings from 3 locations. Seismograph A says, beep boop, I'm 7 miles away from this point. Seismograph B says, beep boop, earthquake is 4 miles away from this point. These are the points where the seismographs are, I should mention. And C says, beep boop, I'm 5 miles away, and I'm at this position. And we had to figure out where the earthquake's epicenter is, where it all works. The spot where all 3 of these circles will meet will be the epicenter of the earthquake. So we're just graphing 3 circles. Let's start with A. A starts at -2, 2.5. So right around here is going to be point A. But since the epicenter is 7 miles away, that means the radius is 7. In order to count this off, we can count 7 in any direction and make a point. That'll be the edge of our circle. So, because we're sort of at a halfway point up and down, I'm just going to count sideways. 1, 2, 3, 4, 5, 6, 7 would be right here. Fun fact, if you didn't have a compass with you, and how could you not bring your trusty compass everywhere you go, the most accurate way to do this would be to actually make the radii on all sides, then connect them with arcs. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 7, but I don't think it'll all fit on here. 2, 3, 4, 5, 6, 7. Oh, just barely on the edge of the frame. What you could do is, if you didn't have a compass, you could just then connect these with arcs. But I do have a compass, and so should you. So we're going to do the more accurate method. Find the center. Find a point which matches up with that center. In this case, B1 seems to match up perfectly. And complete the circle. You go all the way around, and then when you're about to hit your fingers, you can just go backwards. Or you can go under your fingers if need be. Ooh, getting a little bit dicey. There we go. There's our seismograph's reading. It says that the earthquake is somewhere on this ring. Pause the video and see if you can repeat this for B and C. Alright folks, how did we do? As we take a look at these 3 circles, we can see there's one spot where all 3 of them actually meet. It's not right here, because this is inside of circle A, but right here, at this point, on the edge, we have our intersections. It's not an exact science. With circles, it very rarely is. But, to my best estimations, the epicenter of the earthquake was at around 5,2. Maybe it was 4.9, 2 or 4.9, 2.2. We can estimate it if we'd like. But, that's up to you. With that said, folks, we have reached the end of Unit 10. Thank you so much, and I hope you have a great rest of your day.